Okay, so here's the scoop for today. Okay, yesterday we did all these different kinds of factoring methods, right? Which you may or may not be good with at this point, which isn't, you just have to be good with it for the summative.
What?
I don't know. After the break sometime, obviously, but the difference, and then yesterday, so you had all your factoring methods, and then yesterday we did how do I graph when it's written in factored form. So today we're just going to combine the two. You're going to have to factor first, get it into factor form, then do the same stuff we did yesterday, right? So we're just combining what we've done this week. All the factoring, then the plotting of the X-Intercepts, and then finding the axis of symmetry and just producing the graph, right? And then we'll see what happens. The other part of this lesson today is what happens if I can't factor. Okay, I'll redo it. I'll show you. Okay, so let's just start right at the top, right? So, thank you. I have to do the attendance too. So what I want you to do, why don't you guys factor this first, see what you get. Okay, while I do my period 1 attendance. See what you get, and then I'll do it, and then see if we're the same or not. Okay? It's not Friday yet. I almost checked off Friday. Okay, let's do. All right, what's the first thing I would do with this? I've told you this a few times, we just haven't actually done it. Yes.
Put it in the factor.
Okay, we can put it in a factor form, but something before that. What can I read off of here right away? Is there okay? So
What way the parabola is like the.
Okay, yeah, it's opening. Okay, good. No, I wasn't looking for that, but that's okay.
And then also the stretch/compression.
It's opening up, and there is no stretch or compression because the value is 1. You guys paying attention?
Yeah.
Okay. Right. So there is no stretch or compression, so the step pattern stays the same, right? But there's something else. What did I say we could always read off directly from standard form? It's basically the only thing that standard form is good for. Yeah, Ian? There's something about standard form. It's basically the only useful thing we can have for standard form, which is why we have the 2 other forms. And it's what happens if I plug in x equals 0. Right? So like any function machine, right? If I input values of x, like we saw this yesterday, if I input values of x, I get outputs out, right? So what I want to know is, and this is kind of we'll call this the trivial answer. Sometimes this is like what happens when I plug in x equals 0, right? So x equals 0 is along here. What is this? The y-axis. So it's the y-intercept, right? So if I plug in x equals 0, I get 0 squared minus 0 minus 12. Well, that's 0 and that's 0. So what's the y-intercept? Negative 12. So I can plot that point right away, right? That later allows for, like, if I know what the axis of symmetry is, right? Then you can see the point at negative 12 right? Wherever the axis of symmetry is, there's either going to be another point over here or over here, equal distance away from the axis of symmetry. So just another point that you have available to you, right? I'll show you that after. Okay, just trust, let's run with the fact that I can read the x-intercept, or the y-intercept, sorry, right from the equation, right off the bat, and the direction, and if there's a vertical stretch or compression, right? So now the second step would be, okay, let's actually do what we did yesterday, get it into factored form, right? So we're gonna, what's the word I'm looking for? Switch. We'll just say switch to factored form. How do I do that? Okay, factor. So how do we factor? We find the multiples and what adds, right? And then find the two numbers that satisfy both those conditions. So in this one, we want to find two numbers that multiply to negative 12, add to negative 1. Negative 3. What was it? You're right. Okay, so it's 3 and negative 4. Right? That multiplies to negative 12, and then if I add them together, I also get negative 1. So those are the two numbers. And what kind of trinomial do I have here? Complex, perfect square, simple. What do I have? Simple because what? There's a 1 here. Right? So if I have a 1, then I can basically just take whatever signs in front of both these numbers. Right? That's factored form. I've switched it. Now what are the x-intercepts from there?
Where did you get the 3? Oh, never mind.
Okay. So let's plot those. So these are the x-intercepts. We're going to go find negative 3. Then I'm going to find 4. Okay, where's the middle of those two? The next piece will be, let's find the axis of symmetry. We'll do that in blue. Okay. Yes?
So there's 7 in between negative 3, or positive 3 and negative 4. But I guess it's negative 3 and positive 4 there. And then, so 7 divided by 2 is 3.5. So you know that the axis of symmetry is going to be 0.5.
Okay, yeah, so if I count that there's seven squares between the roots, then the middle must be 3.5 on either side, right? So I'm going to start at 1 and I'm going to go, there's 1, 2, 3.5. Okay, so your axis of symmetry is at 0.5. Right? That's the AOS. That goes all the way down. Okay? Now your job is to figure out the vertex. I know the vertex has an x value of what? Negative 12 is the y-intercept. What do I know? If I know that the here's your axis of symmetry, right? Right. The vertex has to be along that blue line somewhere. So I know the x value has to be 0.5, right? Yeah, Ian.
Which is negative 3. The middle number is not the positive 1 on the x. Instead of it being 0 on the y value, would it be positive 1? It's negative 3 and 4. It's not negative 4 and 4, so it's like the line
Yeah.
of symmetry.
Yeah.
Wouldn't it be at positive 1 and not 0?
Does positive 1 look like halfway?
It's negative. It's 3 and negative, or negative 3 and 4 are the
Yeah.
two x values, right?
Yeah.
So it wouldn't have to be negative 4 and 4 for it to be 0.
It's not at 0 though. This is 0.5.
Okay.
You sure? Yeah.
Yeah.
All I did was count 1, 2, 3, 4, 5, 6, 7. What's half of 7? So if I have 3.5, I'm going to count 1, 2, 3 and a half to get to 0.5. Okay. Now these ones are nice. Where it gets a bit complicated and what's difficult to find in the middle is when we have like roots of 1/2 or 2/3 and stuff like that. That's where it starts to get messy, right? Because you don't know where it's harder to find the middle of those two things, right? So okay, so here's my x value of the vertex. Much like what I did earlier when I plugged in x equals 0, I can plug in 0.5 now, and it'll spit out a y for that corresponding x, right? So let's do that. Plug in 0.5, so it's 0.5 squared minus 0.5 minus 12. That'll tell you what the y is for that corresponding 0.5 point, right, for x. So what's 0.5 squared? I think it's 0.25, is it? Minus 0.5 minus 12. So I'm going to get negative 12.75. Does that make sense? So just slightly below. What's interesting is it's like just barely below that black y-intercept that we had earlier, right? But here's the nice thing. If I know that there's a point 1 unit value away from, or half of a unit value away from the axis of symmetry, then I can go out half as well, right? So now you can produce your parabola. That's not the best picture. It's a little tight down there, but right? And your vertex is going to be negative 12.75. Yeah, Ian.
When you get the y equals 0.5 squared minus 0.5 minus 12, why do you put in 0.5?
I think I did the math wrong anyway. Let's just one sec, but I'll answer your question. I did the math wrong. So Aiden, when I want to remember when I plugged in 0 and I found the y-intercept?
Yeah.
That was like an x value of 0. I can plug in any point I want and get out a y, right?
Right.
So if I want to know the value of the graph at negative 10, right? I could plug in negative 10 into the equation and get what the y value is. So I know that the vertex, the point of interest, really is what I care about in order to produce the graph, because I need to know how far down it goes. I know it has to lie along the axis of symmetry, right? So if I plug in this value of 0.5 into the equation, I get the value, or how tall, or like where on that axis of symmetry it falls, or like how high up the y-axis, or how down, like how far down the y-axis it is, right? So I just plug in points to see what's up. Now I've made a little tiny math there.
So you have to plug it into the top. You can't.
Does it matter? Good question. Good question. Let me fix it first. Okay, 0.5 minus a half is not 0.75. 0.25. Right? I'm looking at this. That takes me to negative 0.25 minus 12. So this should be, if you type this in your calculator, you should get this, which doesn't really change your point all that much, but nonetheless. Okay, now Hector's question is a good one. if I've done this correctly, this is just another version of this, right? So if I plug in into this one, 0.5 plus 3 multiplied by 0.5 minus 4, what should the answer be? Should get 3.5. What do you get? I can't do that in my head.
I got 9 something. Maybe I did that wrong. I probably just did my math wrong, so I did it in my head.
12.25.
Yeah, okay, I just can't do that.
That's kind of cool. That's how you know you're right?
Cool.
If you can plug the same point into both of your equations and get the same answer out, then you know it's truly the same parabola, right? So you should get the green. You should get negative 12.725. I almost did it again. Okay. You guys want to try the next one? Factor it. See if you can produce the graph. Remember, and I was explaining it to Bethany yesterday, like you can always check these things. If you produce your graph, go to Desmos. See if your graph matches up with Desmos. You could plug either one of these into Desmos. It'll produce the same picture. See how you compare, if you've done it right or wrong. Okay? I'm going to go drop my